Now we have to study the effect of temperature on the resistivity. How does the resistivity of a substance changes with increasing temperature? In order to study the effect of temperature on resistivity, we divide the substances into three categories. One is called conductor, number two alloy, and number three semiconductor. So in order to study the effect of temperature on a substance, substances are classified into three categories: conductor, alloy, and semiconductor. First of all, we take conductors. Students, we know resistivity is given by rho is equal to m upon n E square T. M upon n E square T. What is m? M is mass of electron. N is called electron density. E is charge on an electron. What is T? T is relaxation time. So when we shall increase the temperature, the collision of the electron with the kernel will become fast. Electrons will move rapidly. They will make frequent collision with the kernel, or we can say relaxation time will decrease. So with increase in temperature, collision of electron with kernels becomes fast. That is, T means relaxation time. Relaxation time decreases. When the relaxation time decreases, rho is proportional to what? 1 upon T. So with decrease in value of T, rho will increase, or we can say with increase in temperature, resistivity of conductors increases. Once again you can see rho is equal to m upon n square T. In this expression, m is mass of the electron, n is electron density, E charge on electron, T is relaxation time. These terms are constant, therefore rho is proportional to 1 upon T. When you will increase the temperature, the collision of the electron with the kernel will become fast, as a result of which relaxation time will decrease, or we can say resistivity will increase. So the conclusion is that with increase in temperature, resistivity of conductor increases. If we will plot a graph, the graph will be in this way. This side we are going to take temperature, this side resistivity, then graph will be a straight line. So in case of conductors, resistivity increases with increase in temperature. Then comes your alloys. In case of alloys, the change in resistivity with temperature is very small, and we neglect it. But in case of alloys, resistivity changes, resistivity increases very slightly. The change is so small that we neglect it. So in case of alloys, there is no change in resistivity. The graph will be of this shape. Temperature, resistivity, the change is negligible. The change is negligible. So we ignore it better. Then comes your semiconductors. Again we can say rho is equal to m upon n E square T. In semiconductor, rho is proportional to what? 1 upon n. In semiconductor, there are no free electrons. There is no question of relaxation time. In case of semiconductor, covalent bonds rupture as we increase the temperature of the semiconductor. When you will increase the temperature of the semiconductor, covalent bonds will rupture, more and more free electrons will be produced, that means N will increase. So, in semiconductor, with increase in temperature, more and more bonds rupture, N increases, so rho decreases. This side temperature, this side resistivity, the graph will be of this shape. So in this way, dear students, you can say that in case of alloys, resistivity, in case of metals, resistivity increase with increased temperature. In case of alloys, the change is negligible, and in case of semiconductor, resistivity decreases with increase in temperature.